In this video, we are going to talk about triangle congruence, some symbols, some notation, vocabulary, and some commonly used theorems. So we'll start with congruence symbol. So first of all, that word congruence, it simply means for something to have the same measure. So for example, in these two triangles that you see here, the sides with one mark are congruent, and the sides with 2 marks are congruent, and the sides with 3 marks are congruent. So anytime you see the word congruent, it just means they have the same measure. So that could be the same side length, it could be the same angle measure in degrees. It simply means that they are equal measures. So sides with the same number of markings are congruent. That goes for sides and for angles. So sides are typically marked with little tick marks. Angles are marked with arches. And then we'll talk about some notation. So these markings lead us right into some more vocabulary that you would need to know. So we talked about what congruent means, but how to write congruence in a shorthand is this equal sign with the squiggle mark above it. That means congruent, or the same measure. We'll also be using the side notation quite a bit. That's just noted by the endpoints of whatever side you're talking about. So just in this example down at the bottom, if I'm talking about this side that I've highlighted, then I can name that side AC with the line above it. We know the line symbol, the angle symbol, and the parallel symbol. Perpendicular is like an upside down capital T. And then I want to note the ways that we can label angles. So I have a diagram down here of these points B, A, and C, and an angle formed by those points. So there are 3 different ways to label any angle. You can label it with just the vertex of the angle. So we could call this angle A. However, if I add on this side D, then technically A has 2 angles. It has the angle from the green angle, and it has this angle now by the green side joined with the black side. So since A technically joins 2 different angles, we need to determine which angle of A that we want to talk about. So if I'm talking about the green angle A, then I would label that either CAB or BAC. Either way, if I'm talking about angle A, that comes in the middle of the 3 points. If I were talking about this angle, then I could label it BAD, or I could label it DAB. Either way, if I'm talking about the angle A is going to be the term or the letter in the middle. All right, some common theorems. Maybe you're wondering, what is a theorem? I've never heard this word before, or maybe you've heard it before and don't know what it means. A theorem is just a mathematical fact. So really what a theorem is a statement that can be proven to be true based on mathematical truths. So these theorems are just mathematical facts that have been proven. The first one is the vertical angles theorem. So anytime you have two lines that intersect, the angles formed on the opposite sides are always congruent. So these two pink angles that are marked are congruent, and also the top is congruent to the bottom. Even if they aren't marked, so if these two were completely unmarked, that would still be true, that the vertical angles would be congruent. So sometimes they won't be marked, and we have to remember that vertical angles are congruent so that we can mark them and use them when we're talking about congruent triangles. The next one is the reflexive property. The reflexive property just tells us that any side, any angle, is congruent to itself. So if I were talking about these two triangles that are joined by the side BA, then I might need this piece of information that this side, BA, is congruent to itself. In other words, it allows you to kind of write that this side, starting from B going to A, is the exact same length as going from A to B. And finally, the triangle sum theorem. This theorem tells us that the sum of the interior angles of a triangle is 180. That means the three angles inside a triangle add up to be 180 degrees. Our first congruent triangles theorem is what we call cpctc for short, because the name of this theorem is very long. This theorem tells us that corresponding parts of congruent triangles are congruent. So what does that mean? Really what it means is that if you have two congruent triangles or two triangles that have all of the same measures, it means that each corresponding side is congruent and each corresponding angle is congruent. So the theorem itself is stated as two triangles are congruent if and only if. So let's stop right there. Two triangles are congruent. Congruent means that they have all the same measures. So two triangles have all the same measures if and only if all of their corresponding sides and angles are congruent. So if we have this pair of triangles down below, triangle ABC and triangle DEF, and I have told you that they are congruent, or we have been told that they're congruent already. So this is our notation for triangle ABC is congruent to triangle DEF. Well, in that case, that means that angle A corresponds to angle D. Okay, so I'm going to mark this so that we can see it. Angle A is congruent to angle D. It also means angle B is congruent to angle E. So I'm going to give those 2 marks. And angle C is congruent to angle F. I'm going to give those 3 marks each. So congruent triangles have congruent corresponding angles. They also have congruent corresponding sides. So side AB is congruent to side DE. They're going to get 1 mark. Side BC is congruent to side EF. They're going to get 2 marks. And side AC is congruent to side DF. They get 3 marks. So notice that the order of this notation matters. If triangle ABC is congruent to triangle DEF, then that is the order that the corresponding parts are congruent in. So, notice that A goes with D, B goes with E, C goes with F. And then when you're talking about the sides, they go in order, starting with the first point, so AB and DE, then BC and EF, then the end points, AC and DF. Let's look at some more examples of labeling and writing statements of congruence between triangles. All right, so first, when we are labeling or when we are marking corresponding sides. So if we're told here in example 1, if we're talking about the corresponding sides of these triangles, then the order that they're listed in tells us which sides are congruent to each other. So VT is congruent to EG. So they have 1 mark each. TU is congruent to GF. So they have 2 marks each. And VU is congruent to EF. So they have 3 marks each. Then if we wanted to write out what these symbols mean, so this information marked on the triangle means these congruent statements. So we could break it up so that we actually have written out that side VT is congruent to EG. We can write out that side TU is congruent to side GF. And we can write out that side VU is congruent to side EF or FE. So example 1 and example 2 are all about corresponding sides. Now let's talk about corresponding angles. So just like in the first example from cpctc notes, we can look at how to label corresponding angles. In this order, triangle UTS is congruent to triangle HIS. So angle U is congruent to angle H. So they get 1 mark each. Angle T is congruent to angle I, so they get 2 marks each. And angle S is congruent to angle S. They get 3 marks each. And angle S is congruent to angle S. The next example, first we have the congruent triangles listed for us. Triangle XZY is congruent to triangle XZD. So the order that they're written in matters a lot. Okay, so angle X is congruent to angle X, so they both get 1 mark. Angle Z is congruent to angle Z on the other triangle, so they both get 2 marks. And then finally, angle Y is congruent to angle D, so they both get 3 marks. Then to write our congruent statement, we can split those up. Angle X is congruent to angle X, and so on. Now going in a little bit of the reverse order, if we have the images of the triangles already marked, we can write the congruent statement from the picture. So in this example, we'll call this one example 5. In example 5, we have these triangles marked. We have to decide what order do we need to write the congruent statement in. When I say congruent statement, I mean it written out with the symbols. So you can see down at the bottom where we have angle U has 1 mark, and up at the top of the next triangle, angle T has 1 mark. So angle U is congruent to angle T. Then we can look at the angles with 2 marks, angle V and angle S. So angle V is congruent to angle S. Then you can see that angle W has 3 marks and the other angle W has 3 marks. So angle W is congruent to angle W. So from this information that we wrote, separating each angle, that tells us the order that we can write the triangle statement in. Let's make this a little more clear. Okay, so we have so we have the first triangle, we listed all those angles on the left, so this would be triangle UVW. So triangle UVW is congruent to the same order that we listed those congruent angles in, TSW. So from our congruent statement up at the top, we can always double check to see, do those angles match up? So U is congruent to T, V was congruent to S, and W was congruent to W. Let's look at the next one in example 5. All right, we start with the angles that have 1 mark, that's A and B. So automatically we can start to write our congruent statements. Angle A is congruent to angle B. Then for the ones with 2 marks, be careful here. Notice that they're conjoined by the same endpoints. So they're still A and B, but notice the order that they're in. So in triangle 1, we had angle A was congruent to angle B in triangle 2. Now in triangle 1, we have angle B is congruent to angle A. And then lastly, in triangle 1, we have angle X is congruent to angle C in triangle 2. So notice these columns are the points of the triangle. So we started in triangle 1 with angle A, and that corresponded to angle B in triangle 2. So our congruence statement is for triangle 1, triangle ABX is congruent to triangle BAC. Finally, we have some where we have to know a little bit about those common theorems that we talked about before we can list out all of the congruent corresponding sides. So we already had TS is congruent to TU, SV is congruent to VU, and then we needed to know this third side. TV is congruent to VT, or vice versa. So if we call this triangle 1 and this triangle 2, it doesn't matter which one you label 1 or 2, but you want to make sure that you've got your points in order. So we have TU is congruent to TS. UV is congruent to SV, and TV is congruent to TV. And this last one. We already had that KD is congruent to ED. So that's what tells us to write them in this order, KD, ED. And then the only points left are J and F. But for this one, we will talk about some theorems later that involve a combination of using sides and angles, but I just wanted to make a note here that because these triangles are formed by two lines that intersect, they do have vertical angles that are congruent.